Um, I am out sick today, and I just decided that we are going to do a video lesson. So please make sure that you have your guided notes and you are able to hear this. I don't know if someone's going to be playing this on the board or if you're going to be listening to this on your computers, but just make sure that you are able to hear me well. Before I get into today's lesson, I want to start off with really emphasizing our pacing in this class. So I want to show you what our curriculum looks like and tell you where we are. So far, we have gotten up to Unit 3. Um, and we have not completed even all of that. So for Unit 1, we did all of we did some of this. We did up to we talked about shapes of distributions. Remember, things are like bell shaped or skewed left or skewed right. Um, we talked about we did our data gallery. We talked about mean, median, mode. We did our 5 number summary. We skipped this middle part and we talked about outliers, if you remember that from Unit 1. We learned about like the definition of statistics and categorical data versus numerical data. In Unit 2, we did this first section. We talked about the pizza party, and if you remember, we talked about like the cost of a main dish, the cost of a side dish, the number of dishes, and we put things into standard form, slope intercept form. We talked about what makes equivalence equations. We talked about their graphs. We did not do this middle part again. Okay, anything talking about solving systems, anything with the word systems in here, we did not do. That those will come up later. We're going to have to come back to those. So we did not do solving systems of substitution by substitution. We did not do solving systems by elimination. But we did do the second half, and we did talk about one variable inequalities. So if you remember, like the alligator eating the bigger number, stuff like that. So we did equations and we did inequalities from Unit 2. We did not do anything with systems. And Unit 3 is what we're on now, and we are currently on Lesson 7. And just so you know, this is our curriculum. This is everything that we have to get through before the end of the year. Before you see the keystones, this is all the stuff that you need to learn. Let me just click into Unit 4 so you can see exactly how much work we still have left ahead of us. And we're halfway through the year already, okay? So when keystones come up, for those of you who keep asking, why can't we have a chill day today? Why can't we just watch a movie? It's because we are so behind. You have a lot to get through before you have the keystones. And if you have not even seen some of this information, you are not going to be able to answer those questions on the keystones. So it is really important that we are moving at a pace where you are able to get through all of this. Now, I do know that the pace that we're moving at is probably unfair for some of you. It's probably perfectly fine for some of you, but for some of you, it is unfair. And I do want to let you know that you are perfectly capable, and I am okay with you doing any sort of enrichment. So, just to make it a little bit easier, if you go to Khan Academy and you use my class code over here in the upper right hand corner, T6VMGQBT, QB2, sorry, you can join my math enrichment course, okay? And I've already assigned our curriculum in there. Go through it, okay? We are not moving at a pace where most students are going to be able to learn all of the eligible content for the keystones in time for the keystones. So if you would like to get ahead, I highly, highly encourage you to just go on Khan Academy or some other um, math platform and learn it on your own. Learn it on your own. If you want, I can incentivize it. You don't have to do Delta Math if you do Khan Academy, okay? I don't really care. But if you feel like you are capable enough to move ahead, then I highly suggest you do it so that way you can perform well on the Keystone. If you can think of some sort of incentives for getting ahead on Khan Academy, let me know when I come back. Email me, whatever. But I highly, highly encourage you, if you feel like you are fine with moving ahead. I can think of several of you who I think would really flourish by doing this. Um, please do. I really shouldn't have to tell you that, okay? But please do what you need to do to be on track and on pace and even ahead of pace, okay? So back to our lesson. um all right. So, okay. All right. So the first task that you're going to see is pretty much a warm up. The directions are to identify and write at least one reason why each of the four scatter plots might not belong. Take 3 minutes to think quietly and write. Then take 3 minutes to share amongst your group and be prepared to share. That's what we were going to do if we were in person. So take, set like a 5 minute timer or whatever and look at each of these four graphs and figure out why each one is different than the others, right? What makes one different than the others? What does one have that's different that the others don't have? Okay. And just write it next to the scatter plot. So you can pause the video now, take some time to get that done, and come back to it when you're done. So now that you've paused the video, ideally, let's go over some things that you might have seen. So for scatter plot A, you might have seen that for scatter plot A, it might not be long because maybe it's the only one with a line of best fit that is positive, right? With a positive slope, right? So the slope of the line of best fit is positive. So maybe you saw that and you said maybe that's the reason why A doesn't belong. You could have said something else. For B, let's say you looked at B and you said, well, it doesn't look like, I can't even imagine a line of best fit. These points, these data points on B all look random, whereas the other ones look like they're kind of clustered together. So maybe you said that B just looks random. Okay, and maybe that's the reason why B doesn't belong. Again, you could have said something else. It's cool. But I just want to kind of get you thinking in the way that you need to start thinking in order to be successful for the rest of this lesson. For C, you might have seen that the line of best fit has a negative slope. So maybe you saw that there was a negative slope for the line of best fit for C. And maybe you saw that the line of best fit for D wouldn't be a line at all. These create what we haven't learned yet. This is called an exponential function. So these follow the shape of an exponential function, like an L shape or a curve, okay? It has a curved line of best fit, okay? It's not linear. Okay, so maybe you saw all of those. Maybe you saw something different. But I do want to really focusing on the lines of best fit when we're talking about scatter plots. All right, so let's move on to our second task. So for task 2, you would have received a sheet of different scatter plots and you were supposed to be arranging them however you saw fit. And you're going to do it twice. And the idea was that you were going to get to a certain place with it, but we're going to do that. I'm going to do that for you so that way you see exactly what you're supposed to see by the end of this. All right, so let's move on and look at the actual. Okay, so on the right are the cards that you would have gotten, and you were supposed to organize them into 2 separate categories either way, okay, however you wanted to with your partners. So let's say that if we looked at some of these cards, we saw that if we compared them, some of them looked random, some of them looked linear, right? Some of them looked like really what they wanted you to notice was that some of them were closer, had more precise, more accurate lines of best fit, and some of them had less accurate lines of best fit. So let's say that we wanted to categorize group 1 as the group where they have very accurate lines of best fit, and group 2 with the ones that are not so accurate. So maybe for A, I would say like I could see that one has a downward trend. Let's put it in accurate. Let's put C in accurate. Let's put B in not accurate. That one is, again, like really random looking. For D, that one looks super linear. For E, that one looks kind of random. It looks like it is probably going up in the positive direction, but not really something that I feel like I could draw a really good line through. For F, definitely an upward trend. For G, also very accurate. So H is very tricky, right? It's kind of doing this like up, down, like a wave. This is you'll learn about that in trigonometry or algebra 2. This would be something more along a sine curve or a cosine if you've heard of that. But it makes like waves. It makes like a W shapes. So I would put that over here. That one's kind of funky. That one I don't know what to do with. So let's put that in group 2. For I, again, it makes a curve. So I can't really draw a line through it. So let's put that over here too. It's kind of funky along with J. Okay. So if you can now take a look at group 1 and group 2. Group 1 are kind of like scatter plots that we've already looked at. We can draw a trend line, a line of best fit that goes through the data, that goes through the center of the data and follows the trend of the data. That is linear, right? It's a line. We can draw a straight line that goes through the data. For group 2, they're either random or the shape that they follow is not linear. So that is one way that you could have categorized these. And for the sake of time, that is exactly what we're going to do. Okay. So again, with a big focus on the line of best fit when it comes to scatter plots. That is very important. The line of best fit tells you where the data is going, right? Like it's like your average. If we go back to our unit 1 when we were talking about averages, our mean, right? It tells you like it helps you project or estimate out into the future, right? So like maybe we don't have data for later on, but we can use our line of best fit to say, okay, well, what if we did have this much? What if we did have this many oranges in the box, right? How much would the box weigh? We can use that to predict, okay? And a lot of statistics and data collection and science is about predicting, right? You take a small group of data, right? And you say, okay, well, what if we extend that out to many people? That's how they come up with all these statistics for your medications, right? They may have just taken a sample of 10 people and given them this medication, right? And they get the data for that and they say, okay, well, what if we gave it to 100 people? They don't actually give it to 100 people. They just use the data and they extend it out. They just pretend that it's bigger. Okay. So we would have taken a break. If you want to take a break at this time, just go to another tab, set a 5-minute timer for yourself, or if a teacher is showing this on the board, then the teacher can set a 5-minute timer, but just be mindful of your time. I'm perfectly fine with you taking a break at this point, but make sure that you're coming back to your work and make sure that you're also writing this on your paper. So if you haven't written what I just wrote down on your paper, then make sure you write it down and then take your break. All right, so here is the meat and potatoes of this lesson. We are going to be talking about this thing here. Oops, it says escape. Okay, I don't want it to. It's covering the thing I need you to see. Okay. The correlation coefficient. I'm going to read the definition and then I'm going to tell you, I'm going to kind of break it down for you. So correlation coefficient, a number between -1 and 1 that describes the strength and direction of a linear association between two numerical variables. The sign of the correlation coefficient is the same as the sign of the slope of the best fit line. The closer the correlation coefficient is to 0, the weaker the linear relationship. When the correlation coefficient is closer to 1 or -1, the linear model fits the data better. You can kind of ignore that second paragraph. Ooh. I think we can ignore that. All right. So basically, the correlation coefficient tells us how good our line of best fit is for our data. So if you look at this first scatter plot, we'll call this one A. So if we look at scatter plot A, we can see that our line of best fit, all of our points in our scatter plot are really close to our line of best fit. our points are almost linear. It would be really easy to see the trend of this data, right? We can really easily draw. So this would have a very strong correlation coefficient. We use the variable r, a lowercase r, to represent our correlation coefficient. And basically what that means is this would have a positive, that's a plus sign. This would have a positive slope, so our r would be positive, and it would be close to +1. Okay, so it'd be really close to +1. Not exactly, because it's all the points are not on the line. Like, think of 1 and -1 as like all of the points are on the line, are on your line of best fit. Basically, all of the points just make a straight line. That's a 1. That's a really, really strong correlation or association. This one's pretty strong. So let's say, like, if we wanted to estimate this one would probably be like positive, like, let's say 0.98 or something like that, right? This is pretty strong. This is a pretty strong correlation. There's a pretty strong association here. Okay, but it'd be positive because the slope is going up. The slope is positive, and it'd be really close to 1 because the correlation is strong. Now let's take a look at, let's call this one scatter plot B. Well, scatter plot B, our R is also going to be positive because our data is trending up, but our line of best fit is not that strong. Our correlation coefficient is not going to be that strong. So let's say that it's going to be positive. Our R is going to be positive because again, our data is trending up, but it's not really that strong. So let's say this will be like a 0.4 or something like that, right? Because again, if we go back, the closer it is to 0, the weaker the linear relationship. So this is not a really strong correlation. This is not a really strong association. So it's going to be closer to 0. And think of 0 as like those random scatter plots where you would be like, where the heck do I even draw a line? It just looks like the data is random, right? There is no association. There is no correlation. That would be a 0. So this is not random, right? There's obviously a trend, or a not so obvious, right? There's not so obviously a trend. So this would be a pretty weak data set. And if we call this last one C, well, our R, our correlation coefficient here, would be negative because our line is trending downward. But again, it's pretty strong. Like, it looks like A just in reverse. So let's say that this would be like negative 0.98. Okay, it's a pretty strong correlation. The line of best fit is a really accurate line for the data. So it's going to be closer to -1. Okay, and again, it's just between 1 and -1. It doesn't go into the 2s or 3s or anything like that. And if it's closer to 0, it's weaker. If it's closer to -1 or +1, then it's really, really strong. And we're going to see that on the next screen. All right, so this is just some examples. So actually, let me separate this into 2 sections. So it's going to look at the top half and versus the bottom half. So the top half all has positive has positive R's. So for this first graph, you see that the R here is like 0.46. Oops. Shike. So the R for this one is 0.46, right? It's really weak. The points are not very linear. For the second one over here, it's you can't see that. It's 0.94, right? It's pretty strong. Okay, if you look at where the points are trending, right? They're definitely going up. It's a pretty accurate line of best fit. And here we have a correlation coefficient of 1. That's the strongest one that you can have. So all of the points are on the line. All of the points are just making one straight line that is on the line of best fit. So this is an example of like the strongest type of association that you can have. If we look at the bottom, we're just looking at some negatives. So again, this first one, I'll do these ones in pink. Let's do pink. So if we look at the first one's negative 0.6, right? Remember, like 0.6 is not that great. Okay, it's there. We could draw our line of best fit. We can see the data is definitely trending downward. That's why they're all negative, but it's not that strong. 0.88 is pretty strong. That's pretty close to -1. But -1, again, the strongest correlation, the strongest association, the best line of best fit, okay? All of the points are on your line. There is no question about it, right? There is definitely an association between the variables X and Y. There is definitely an association, a correlation, a relationship between X and Y, okay? All right, and I don't know what's happening here, but match. Oh, you know what I did? I know what I did. Hold on, I'll be right back. All right, hopefully I fixed it on the next slide, but for the next one, you are going to be matching the correlation coefficients with their respective scatter plot. And I'll just do a couple of examples here. So this is what your task 3 should look like. So starting off with a correlation coefficient of 1, -1. And these do go in order from smallest to largest. So from -1 all the way up to +1 are in order. So if we're looking for a -1, we're looking for a line with a negative trend that has the strongest correlation. So this one has a positive correlation, so that's not it. Positive. This one's negative and pretty strong, but again, it has to be the strongest. -1 is the strongest negative correlation. This one's not as strong. This one, it has to be this one, right? All the points are on the line. So I couldn't really fit all these really nicely, but just draw like a arrow to it or something like that, right? This scatter plot to this R, okay? And I'm just going to do the 2 easiest ones and let y'all figure out the rest of them, everything else in between. So let's just do +1. So +1, looking at all of these, again, we're looking for the strongest positive correlation. So the strongest line of best fit with a positive slope. So that would be this one right here. Okay. And for the rest of them, I guess you could figure out. So this next R, -0.95 would be like the next strongest negative correlation, right? Do I want to? No, I'll let y'all figure it out. So work together, figure out how to match the rest of these. Check your work against the people at your table, see if you agree, disagree. And if you're disagreeing, make sure that you have a reason that you can explain to your partner as to why they're wrong and you're right, right? Like, don't just be like, oh, I don't know, I just picked it, because then your argument's not strong. Okay, if we're talking about the strength of relationships, if and you can't even explain why yours is stronger, then I'm not trusting you. Okay, so make sure that when you are having like these disagreements, that you are prepared to share why. Okay, so you can check your work against the people at your table. You can work with Miss Romolini if you have her, or whoever else is in the room. I guess you guys can email me. Like, I'm sick, I'm not dead. So email me. I believe you can send me chats. If you go into Gmail and go to like chat, I believe you can send chats to me. So if you have any questions, you can reach out to me. I'm alive. Just not feeling great. Yeah. So any questions, shoot me an email, shoot me a chat. And I will hopefully see you guys soon, and hopefully this makes sense. Have a great day, y'all.